Hello and welcome to 5-Minute Math. Today we are looking at the Algebra 1 concept of solutions for systems of equations. This is standard A.3F in the great state of Texas, and we are using item number 32 of the 2016 released STAAR test. If you haven't done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. So we have 4 different graphs. We're looking for the one that is containing the solution. So we have intersecting lines here, and these are all just linear functions. So the solution is going to be the intersection. So we're looking for the one point that will satisfy both systems. Well, we've got a few options. One option would be to find these points. It does look like each of them land right on an integer here. So you could take the x and the y value from f, g, h, and j, and then you can substitute both of those into each of these equations. And if you get a true statement for both, that is the solution. I'm going to show you a different method. This method is called the elimination method. I think it's a little bit faster, but the other substitution method would work as well. So elimination, what does that mean? Well, when we are going to do the elimination, we need both of these first off in standard form, right? So we're looking for ax plus by equals c. So our first one is looking pretty good. 2x plus y equals -4. Now the other one is, for the most part, in slope-intercept. We would just need to divide both sides by -3. We can get that slope-intercept form. But I don't want it to be in slope-intercept. I want it to be in standard form. So I'm going to do that over here. -3y equals 2x plus 12. Right, so if I just subtract 2x from both sides, I'm going to get -2x minus 3y equals 12, right? Now it looks like it's standard form. -2x minus 3y equals 12. Now, since we know that these two lines do intersect and have a solution, take a look at if I were just to add these two equations together, just add straight down, because I've lined them up there. Look what happens when I have a 2x and a -2x. That eliminates, and that's what I'm looking for. Sometimes it'll line up perfectly like that. Sometimes you might have to multiply one of the equations by a number to get the coefficients to line up exactly, but I've got a 2x and a -2x. It's exactly what I want. So that's a 0, so that's gone. So now I have a -3y and positive y, so that's going to be -2y. -2y equals, and then I've got -4 plus 12. That's like 12 minus 4, right? So now I've got my -2y equals 8. I can solve for that y. Divide both sides by -2, right? And you're going to get y equals -4. So I know that my y value of my equation is going to be -4, right? So right now it's looking like f, because I see that at -4. But in order to get the x value, you don't just eyeball it. You actually plug it back into one of the equations. You can plug it into both if you want to. Let's plug it back into this first one. 2x, and then instead of plus y, I'm going to do -4 equals -4. So add 4 to both sides, right? And you're just going to end up getting 0. Okay, 2x equals 0. So x is 0 over 2. So that's just 0. All right, so it looks like my coordinates are going to be 0, -4. If you want, you can plug in that -4 to this first one right here, and guess what you'd get? You would get 12 equals 2x plus 12, and then you subtract 12 from both sides, and guess what? You get the same thing. You end up getting 0 equals 2x, so x equals 0. Either way. So our coordinate is going to be 0, -4. We see that is our y-intercept right there. So that is our solution for f, and f is our answer.